All right. Welcome, everyone. Today we have another very exciting show ahead of us. As many of you have seen, we released a tokenization framework last week, and because it's such a fundamental change of IOTA, right? We're moving away from the IOTA token being the only citizen, so to say, in this IOTA ecosystem to a world where we have many assets, many different tokens sitting in the IOTA ledger. And we're going even beyond that because it's not just about tokenization, it's also about adding real utility via smart contracts to the IOTA ledger. And today we have Levent on the show, who is one of the main architects of the tokenization framework. So I'll get him onto the show in a couple of minutes. And we also have some questions from all of you from the Reddit AMA. So I think we'll have a very good show. Before I get into the tokenization framework, I think it's important to understand how we actually came to this stage and also sort of what the current focus is, because it's kind of obvious that IOTA is currently undergoing a transformation, right? We had a strong focus on the Internet of Things. Like that is really what led many of you to actually join IOTA, right? Because it was all about creating this machine economy and creating a sort of currency or backbone for the Internet of Things. And over the last couple of years, I would say that our vision of the future has actually broadened, right? It's not just about the Internet of Things. It's not just about the machine economy, but it's about IOTA becoming this base ledger, this foundational layer on which different networks and different token economies can actually be launched, right? Where they're all being secured and where they're all being connected through the IOTA ledger. And the main reason why that is actually possible is because IOTA is the only full DAG-based ledger, right? We don't use a blockchain, but we use a directed acyclic graph with the IOTA Tangle. And because of this multi-threaded architecture, we're actually able to host this multi-chain, multi-asset future now. Because transactions and actions can be confirmed in parallel. They're not being serialized, and the network is not being limited by transaction fees and is not being limited by the throughput of the network, right? So this is really where we are right now undergoing this transformation. And it's actually been something that is more than a year in the making, right? If you guys hear about an announcement like the tokenization framework or the smart contracts beta, which it was like, I think 2 or 3 weeks ago, these things take time, right? Because it's not just that one day after another you can say, hey, let's add real utility to the network. All of this has been part of this transformation that we actually started a year ago. And a year ago, people within the foundation and also community members came together and said that we really need to shift our narrative and shift our focus and really move towards making IOTA one of the most adopted ledgers, not just in the real world, but also becoming one of the main players in the entire crypto world, right? Because quite frankly, IOTA today is in a sort of an interesting situation where we are part of the crypto market, but we're not really playing in the crypto market, right? We never really spoke about NFTs, DeFi, and quite frankly, we always saw ourselves as going against the stream, as having a different strategy, so that it's not about being a follower, but it's being a leader in a different domain. And I think now with these new major innovations coming to the IOTA mainnet, and with this huge upgrade, this utility upgrade coming to IOTA, we have a clear strategy of becoming a leader in the crypto market as well, right? Because it's kind of obvious at this point that crypto is here to stay. Crypto is the future. 2017 was a year where we had so many overhyped and crazy ideas of what the future looks like. And I think now in 2021, we have this tangible adoption that is happening right in front of us and is happening in the crypto space. It's not being driven by big companies or by governments, but it's really driven by all of you, right? By developers, builders who have crazy ideas and who want to innovate with technology. to solve problems and to just try things out, right? So I think that's really where we are headed with IOTA as well, where it's about having a clear focus on adding utility on the base layer, adding utility that's not possible on the other ledgers, right? Because they're blockchain based, because they're simply proof of stake based and focus on just EVM compatibility and stuff like that. We have a clear focus on being unique about the developer experience and the features that we offer to builders. And over the next few weeks, it will become a lot more obvious as well what we've been working on and what we've been focused on over the last year. So I'm very happy to be able to share all of that with you guys, so that we can build the future and have fun doing it, right? So without further ado, let me get Levente onto the show.
Hey, hello.
Hey, Levente.
Yeah, I can hear you. Can you hear me?
Yeah, I can hear well. Let me actually just change this. This looks better. Cool. How are you doing?
Yeah, I'm actually having a little bit of a cough, so don't be surprised if I just do some coughs in the meantime, because last week I was kind of battling the man flu.
Yeah, this I think this and spring is usually the worst time to get sick. So
Oh yeah, the weather is just terrible outside.
Yeah, totally. But let's talk about some interesting stuff. So maybe you want to give a quick introduction about what you've been working on and what you're focused on in IOTA.
Yeah. So I've been with the project for, well, let's say a little bit more than 2 years now. Started out as a software engineer, worked on the client side, the libraries, and then I sort of transitioned into working for the Core Decide project as a research engineer. And actually there where all the fun started happening with all these tokenization and smart contract stuff. So yeah, I would like to put it into context, like how this whole tokenization framework and how this support for the new output types actually came to existence. So I think many of you remember last year, actually it was earlier this year, we shared something which we dubbed colored coins or tech coins, which was basically the first ideas we had with regards to tokenization. And we played around with it in our Poland network and see the limitations and what we can do and we cannot do with that. Also, we talked a lot to partners about it. So all these problems became imminent, and we could clearly see that there is a gap which we need to fill in our thinking. So after experimenting with this in the IOTA 2.0 DevNet, we basically took the time to reflect on the decisions that we made before, and basically came up with a new framework. And that's what you have seen last week. That's the result of what we have been working on for the past weeks and months. Not only me, like many other people in the foundation and also in the community. I really want to thank the X teams, for example, who helped us to shape this. So we've been working a lot together to bring this to the table and basically rethought all the features of this tokenization framework. So we basically imagined this token wonderland, which is also was there in the blog post, where anyone can create tokens on IOTA. We want to break out from the current concept of IOTA, which is just it's like a token for IoTs and then machine economy. Yeah, it's really great, but we have to face the real world and the crypto market, and we have to sort of cater to the needs of that market. And tokenization and smart contracts, I think these are the two most important topics right now, as we've seen with the hype around NFTs and the different DeFi applications and so. So we wanted to build a system which makes it possible to run all these applications on top of IOTA. And I want to sort of emphasize here that we are running all this stuff on top of IOTA, which is a feeless based layer. So it's a perfect foundation to provide all this utility so that higher layer applications can use it. And what is even better is that, for example, smart contracts, if you regard them as layer 2 applications, they have now a standardized way of communicating with each other. not just data, but also value. And I think this is really unique in our approach. This is not something I regularly see in other projects.
Yeah, I mean, it's really exciting how this all started with the IOTA 2.0 DevNet, right? Which was sort of like the breeding ground of some crazy ideas, not just about core design.
Yeah, and I just want to highlight here, like for me personally, the moment when we released these onto the IOTA DevNet and finally people could, create their own tokens and trade with it, you've just seen so much excitement around around the community. It was actually a really good feeling as being an IF developer to see people actually using stuff which we build.
Yeah, and I mean, this is really what we live for, and for us in the foundation, but also in the community. Like, for me, the most amazing moments in the community is like when somebody just launches a new project and a new token, and you don't even know about it, right? It's like, oh, like that's cool, right? Like for example, the IOTA bots.
It's a really uplifting thing. Actually, I missed IOTA bots, so I hope they will do another airdrop.
Some people will say, "Have fun staying poor," because they have so many bots. But let's try and unwrap this a little bit. So the IOTA 1.0 mainnet, right? We had bundles, we had Winternit's one-time signatures. Then came Chrysalis, which came out, I think, April last year.
Yeah, it was April.
Yeah, April last year.
But wasn't it this year? No, I don't know. Yeah, it was this year, no?
It was this year?
No. Sorry, I'm confused.
Me too. It's kind of funny because, like being in crypto, you're living a different time scale, right? Because you just move so fast.
Everything is just so fast.
And everybody's just so focused on all of these different things. It was this year, actually, by the way. So I got it wrong. So the way that Chrysalis was actually positioned is that it's, first of all, a stepping stone towards IOTA 2.0. But more importantly, it actually introduced, it completely re-engineered IOTA from the ground up, right? It's a complete new protocol, so to say. And we are using now UTXO. We are now using EDDSA, right? Which allows reusable signatures and addresses. And all of these combined actually build a very solid foundation to introduce some exciting new concepts. So, and obviously tokenization is the main one, because the tokenization framework so far was only possible on the IOTA 2.0 DevNet because it has the UTXO model, right?
Yeah, exactly. So with this shift to the UTXO scheme with Chrysalis, we basically laid the foundation for what comes next.
Yeah.
And this was first, I think it was even implemented before Chrysalis happened. It was even before it was implemented on the IOTA 2.0 DevNet. So by working hands-on with that, we could already get like a feeling of what is possible, and yeah, of course, what is not possible as well. But this UTXO model, which we transitioned to, actually opened a lot of doors for us. And we design it in a way that it's additive. So if we figure out, or the community figures out, for example, that some exciting new features which nobody ever thought of must be part of the protocol, well, be my guest and do it. It's possible because we designed the system in a way that you can always extend it.
Right. Yeah, that's super powerful, right? And future-proofing the ledger, basically. So let's talk about our tokenization framework, because I think there's two different shifts, two different ways to do this, right? So Bitcoin had this concept of colored tokens or tinted tokens, where I think it was through the opcode codes part there, where you could actually
yes and no,
define data.
It was sort of like a layer 2 application. Like you put your colors or tags into outputs on Bitcoin, and then wallets which could understand it can actually do the transactions. So it was not strictly part of the core protocol, so to speak, but something which was built with the core protocol.
Right. And so these scripting capabilities that Bitcoin has are basically very limited to certain conditions. It's basically conditions on how transactions can be spent.
right? Yeah, basically they are really, really dumb smart contracts, because you have just a really limited set of what you can do, and you have a limited space, and you have a limited instruction set. So, and some things are purposely forbidden, for example, loops and stuff like that. So actually your hands are pretty tied. And I think the big innovation which happened after Bitcoin, that was Ethereum, is what generalized this concept of programming the ledger. And and Ethereum did it in a way in which they solved like one of the most fundamental problems, which was the programmability of the ledger and how you limit access to this programmable ledger. And that's also, by the way, the consequence why we see the huge transaction fees in Ethereum. So we want to do something different, and we want to do something which is more scalable, at least from horizontal point of view.
Yeah. I mean, so we have this limited scripting capability, which is more secure but also more scalable, which Bitcoin has today. And then we have the infinite possibilities, so to say, that Ethereum has. But we have fee markets there. We have complexity and obviously security problems that might happen in the future, right? Because it's hugely complex to do this stuff. Now, the way that we are thinking about this is actually combining both of these concepts to get the best of both worlds.
Yeah, I mean, we chose an architecture which is a hybrid architecture. So our base layer, the IOTA network, that is a really powerful and performant and scalable ledger compared to Ethereum or even Bitcoin. But it also makes it possible to outsource such infinite programming capabilities or infinite opportunities, as you put it, to layer 2 applications. And smart contracts, for example, are an example of that. You can program a smart contract chain in IOTA the very same way you program Ethereum. So it gives you the option as a developer to choose, okay, does my use case require this advanced programmability? If yes, then probably you should do it on a smart contract chain. However, if my use case requires feeless transfers and ultimate freedom, then why not do it on layer 1?
Yeah, I mean, the whole idea behind this is to really offer freedom and flexibility to the developers, because we have layer 1 and we have layer 2. And with unique USPs on each layer. But I think the beauty, like what really clicked for me when I was thinking about this, was how both can fit so beautifully together, right? How layer 1 tokens can be wrapped onto the layer 1, and how they can actually secure and actually connect the different smart contract chains. Because one of the difficulties that, for example, all the wrapping solutions on Ethereum have today, and also what the sort of layer 2 solutions on Ethereum have, is this interoperability problem. How do you go from one layer 2 network to another layer 2 network, right? There's no way for them to easily transfer assets. Now, with our solution, we actually use IOTA as a data/token transfer layer, right? And they can do it feelessly between each other.
Yeah, essentially what we have is a trustless asset bridge between smart contract chains. But maybe it would be also great to just take a little step back and first clearly separate the boundaries between what we mean when we say layer 1 or tokenization framework, and what we mean when we say smart contract tokens or layer 2 tokens, because these are fundamentally different things. So for starters, all the native tokens, as we call them, they are the tokens which live inside the IOTA layer 1 ledger. So these are tokens which are tracked in the very same UTXO framework as the network uses for regular IOTA transfers. So any token which is present in this native token framework, that actually inherits all the security and scalability of the base layers, so IOTA. On the other hand, it also inherits all the permissionless properties of those tokens. So if you have a layer 1 token in your pocket, in your wallet, then it belongs to you and nobody else. It's not like there is a smart contract somewhere up in the blockchain, which can freeze your assets or seize it or just stop trading at all. Like, it cannot happen on layer 1, that anybody is restricting your access to your own possessions. Right. And I think this is really important. So the other form of tokenization, sorry, Dom, just to quickly finish it off, is what we call layer 2 tokenization. And this is what we mean when you tokenize stuff on layer 2 smart contract chains. So exactly with these new smart contract beta, for example, you can already do that. And I've seen already people, actually, I also deployed my own token on the beta network.
Levi coin.
I don't remember how I called it. Yeah. But the thing is that when you tokenize stuff on layer 2 with smart contracts, then it is familiar to developers in the crypto space, because it's just exactly the same as how Ethereum does it. So you have a smart contract, and the smart contract itself basically maintains a ledger inside the contract, which records who owns what. And then whenever you want to transfer stuff, then you have to call this smart contract and say, hey, modify the entry in your ledger. I sent my tokens to Alias or Bob. So this gives you a lot of freedom when you want to program what is possible and what you allow users to do and how you do it. It's really powerful. But on the other hand, this also means that you do it in an account-based layer 2 smart contract chains, which have similar scalability properties as other platforms as well. But what we want to achieve with our tokenization framework is that we want to provide the option for developers to either use layer 1 or layer 2, depending on your use case, but also give you the opportunity to walk in between these two worlds. Like, you don't need a bridge solution. You don't need an external third party to verify moving assets between smart contracts and the layer 1. Everything is built into the system, so that all you have to do is basically call a core contract on layer 2 and say, hey, take my layer 2 assets, wrap them into a layer 1 thing, and send it to me on layer 1.
Yeah.
So it's really powerful because it doesn't really require trust, and it's also way cheaper than using any centralized bridge solution.
Yeah, I mean, one example that I always also like, or one definition that I kind of like, is also calling them first-class citizens of the protocol, right? Because the first-class citizen of the Ethereum network is the Ether token, which is being used for gas for smart contracts. But if you like the most efficient way to transfer on tokens on Ethereum is on layer 1, right? On the base layer with the Ether token, right? Because as you said, everywhere else, if you have an ERC20 token today, you need to call the smart contract. The smart contract then has to do some computation, which is going to cost you more fees. And only then will it be, it's like a bank, right? Like it goes from one account to another account.
Yeah, we like to use this metaphor of bank and cash. So in this context, then the bank is the smart contract, which holds your account on your behalf. Of course, only you, I mean, if you verify that it's you can move the token. But the bank can do all magical stuff with your assets and allow or do not allow whatever they want. But as soon as the bank decides to print cash, that is the equivalent of layer 1 tokens. And cash, as we know, can circulate in the economy without any restrictions. So that gives the freedom to users to actually leverage on these properties and not be tied to, for example, one specific implementation of one specific smart contract. But they can move their assets in between chains, they can wrap them and unwrap them seamlessly. So I think it really gives back the power to developers to decide how their tokens and how their tokens will be used and what their use case requires.
Yeah, I mean, you mentioned this before, right? Having these native tokens, they have the same properties as the IOTA token. They're feeless, they're as scalable, and they have the same level of access as the IOTA token has today, right? Where IOTA is integrated, those native tokens can also be easily integrated. So maybe you want to go through the RFC real quick, so we can highlight what the changes actually are.
Yeah, I'm happy to do that.
Let me share my screen again.
I mean, the RFCs are a little bit technical, so I understand if it's not easily readable for many.
Yeah, I think the high level summaries are already really great and really get you thinking about what's possible in the future.
Yeah. So in the beginning, I would like to highlight that these RFC, or not just this one, there is another one as well, but they are sort of part of the big package. So tokenization and smart contracts, they go hand in hand. So the technical support for both is what is described in these documents. And they are quite frankly inseparable. So what we set out to do, and what the summary part of this document also describes, is that we want to provide support to run the smart contracts, the IOTA smart contracts on top of our mainnet, and also to be able to do tokenization. And after carefully evaluating all the functional requirements of both use cases and both applications, we came up with what we call the different output types. So in general, we introduce 4 new output types into the ledger, which are listed there as alias output, extended output, foundry outputs, and NFT outputs. Now, some of you, I'm sure, don't really get what an output is. It's actually a term which is used with the unspent transaction output model. So what it actually means is that the way the network tracks who owns what is by tracking each individual transaction and checking what inputs are used to fund the transactions and what outputs the transaction creates. So this is basically an accounting system.
Yeah.
So far, at what is currently live in Chrysalis, you only have, well, 1 or maybe 2 types of outputs, because the only use case which is possible is transferring IOTA tokens. So you don't really need much variety there. But as soon as you want to provide support for smart contracts and tokenization, well, suddenly you need to add more output types which present special validation constraints to the network. So without further ado, maybe let's venture into what is in the document. These different output types will be discussed later.
Yeah. You want me to go? Yeah.
It's okay right there. Yeah. So the first part was mainly about motivation. And this is just an introduction into what we already talked about, the ledger programmability with Bitcoin scripts and Ethereum. And we also mentioned, I guess, Cardano there, because they're doing really great work with pioneering these UTXO programmability concepts.
No, we should definitely talk about that afterwards, by the way, because I think it's important to also draw some, but we can do it afterwards.
Sure, we can do that. So here we evaluated basically what it means if a ledger is programmable, what are the technical constraints and validations which you have to follow. And I think the one sentence in the bottom, which is in bold, that summarizes what we arrived at, that it's actually not possible currently to provide full-scale Turing-complete programmability on the base layer of IOTA. And that is because our fundamental architecture, because we are feeless, and in IOTA there are no miners and users. There are only, they are sort of one. So everybody validates everything, and it doesn't, because of the feelessness, you don't have to pay to miners or validators to include your transactions in the ledger. But as a consequence of this technical concept, we have to be overly restrictive on how we can program our ledger. And the route we chose was basically to provide hard-coded but configurable scripts, which you can include in your transaction, which support aforementioned use cases like tokenization and smart contracts. I can imagine in the future maybe more, not just more use cases, but also advanced programmability, but it will require us to rethink a little bit about the architecture. Anyway, what's good about this approach, and what you highlighted over there, is that it keeps layer 1 as scalable as it can get, and also enables us to provide really big support for anything on layer 2, like smart contracts or any virtual machines. So it doesn't matter if your virtual machine is based on EVM or VESM or whatever, you can easily integrate it with these new output types. All right, maybe let's go further down a little bit. And these are not really important, just some global parameters and stuff. Okay, so stop there, please, with the table. So this is quite an important change. So basically what we do is we update how transactions are processed on our network. And this means that we add new rules to how transactions can or should be validated. And as a consequence, we sort of had to fine-tune a little bit our Chrysalis concepts. Nothing changes big time. It's just rather some small little changes. But what is most important, as you can see, this is a structure of a transaction in IOTA. And the outputs, the list of outputs which are supported, actually there are now 5. So previously we only had the thing called simple output on the bottom. Yeah, you can do that. So that is what our current mainnet is capable of doing, transferring IOTA coins. And with all these new output types, which we will discuss later, we basically make the ledger more feature rich, and we add a lot of utility to it. So this means that we had to a little bit adjust the protocol as well.
Just really quick a question. Each of these output types has different conditions that need to be met for the transaction to be validated in the network, right?
Yes, exactly. So depending on what outputs are present in your transactions, different rules might apply. So this is actually how you as a developer can take the best of this framework and just use whatever you need for the use case and configure it, and then also be able to tailor it, because it's one thing that there is an output type, but basically depending on what you put inside an output, what parameters you put there, what addresses you put there, you can modify the behavior quite a lot. And I think that is a powerful concept here.
Totally.
All right. Another new thing which is down at the bottom is the unlock blocks. You might wonder why we have some stuff which is called alias unlock block or NFT unlock block. Well, I think we will also talk about it a little bit later, but for now, it should be enough to just say that with this tokenization update, it is not only possible to hold or control accounts on the IOTA network with private keys, but you can also control accounts on the IOTA network with NFTs. You can have an NFT which owns stuff and basically functions as a wallet. You can aggregate stuff. NFTs can own other NFTs, and you can sell the collection or just parts. You can basically send money to an NFT as well. So it opens up a huge opportunity of use cases, I think.
So they basically become their own wallets. They become their own, network participants.
Yeah, NFTs might very well become network participants, or they can be used as proxy wallets.
They become sentient.
Or a DAO.
Oh yeah, with DAOs, this is super exciting as well, right?
Yeah, exactly. So there's a lot of untapped potential here, which I'm sure we couldn't have thought about all the possible use cases, but that's why it's great to have such a lovely community, because I'm sure they will come up with really innovative use cases.
Yeah, I mean, the possibilities enabled through this are really so vast, and we can only make assumptions right now on what can be built, so it will be very interesting.
Yeah. All right, let's skip a little bit, because these are just pure validation rules. I don't think everybody's here for the tech, or at least not for this specification level thingy.
1 second, Levente.
Yeah.
Wait, I think my screen, I think the broadcasting software sometimes hangs. Maybe like I'm just trying to wrap my head around the unlock block stuff because I don't fully get that right now. What does that mean exactly, that you have an unlock block, and what does it change?
All right. So an unlock block is basically, imagine transactions and inputs and outputs of a transaction as boxes. So each box holds IOTA funds. So if I want to spend this IOTA, I have to unlock the block, unlock the box. So how does the protocol know if I am allowed to unlock that box or not? Well, I have to provide a valid signature, or at least somehow prove that indeed I'm the owner of that box. And previously, or at least what is currently out there in the mainnet, the only way for you to do that is to say, hey, here is my digital signature. This verifies that I own this box. But with the new tokenization framework, what you can do is you can say, hey, this box is owned by an address, but that address is not controlled by cryptographic private keys. That address actually is controlled by whoever controls that other address.
Mm-hmm.
So
fascinating.
So basically what happens is you can have global addresses in the Tango. Behind those global addresses, you can rotate or shift your keys, so you don't have to reuse any keys more than once. And bam, you can have a wallet on layer 1 with a permanent address, but you never reveal or you never sign anything with the same key twice. That's the importance of this whole unlock block concept.
Yeah, I mean, like you can really see that there was a lot of thought went into this entire RFC and a lot of experience and feedback also from the current crypto ecosystem come up with this stuff. So that's really amazing.
Yeah, I mean, it's pretty hard to understand the full or grasp the full implications of these, because it has to be a technical paper enough so that the developers can understand it, and we can do formal analysis on these. So I understand why it's hard for most people to get it, but that's why we are here, to give an update and try to guide you guys in the right direction.
Yeah,
and
exactly.
Also those questions.
And where do you want me to go?
Maybe let's go down a little bit. There should be somewhere down. Summary of changes. The summary of changes. It's also a little bit technical, but it's just like a little bit. So that deprecating basically renaming the old output to a new name, just for clarity. We introduced new output types. We have some protocol validation. It doesn't really matter that much. Let's focus on the new concepts. So from here, everything you see is what we baked over the last couple weeks and months. So for starters, we want to make, as you said, native tokens a first-class citizen in the IOTA network. And the best way to do that is to directly add support to all output types. And we do this by basically adding new fields, optional fields, to all outputs, which we called native tokens. So that little table there summarizes that, for example, in an output, you can have a lot of native tokens which have each a token ID, so an identifier, and they have an amount. So the token ID is just the globally unique identifier of a token. So I just wanted to say here that we will discuss later how it is generated, but it's enough for you to know that there can never be two tokens with the same token IDs inside the ledger. So it cannot happen that you create Domcoin and I create Levicoin and they both have the same identifier. This has like a 0.000 many more 0.0001% chance. Technically, not gonna happen.
Right.
So moving forward, we added a new suite of features which we call optional output blocks. So these have nothing to do with the blocks in blockchain. This is just how we named it. Imagine it as basically like Lego building blocks. So you can take these building blocks and you can build your own output or customize your own output. You can build whatever you want. And if you, depending on what building blocks you put into an output, its functionality is extended. So for example, the first one, what we see here as a sender block, that is actually something which naturally were born out of the needs for smart contracts. So imagine that you send a request to a smart contract with a transaction on like an on-ledger request on the IOTA network. How does the smart contract know who sent this request? Like all they see is an output was created to my address with such a data and commands and whatever, but who sent it? Well, the layer 2 nodes would need to examine how the transaction looks like and try to infer, okay, who could have been the sender? But instead, you can just put a Lego-like building block, sender block into the output. And then the protocol takes care of validating that whoever claims to be the sender actually did sign the transaction. So you don't really have to care about it anymore. And you can be sure that this request must have been sent by someone who approved that transaction. So this is an absolute necessity for smart contract support. Also, it is used for the tokenization framework, which I will talk about a little bit down there. So yeah, just an interesting note there. As you can see, these address types and stuff. So usually, since Chrysalis, our addresses look like IOTA 1Q something most of the time. So what we did is that to help users basically check who they are sending funds to, we designed the system in a way that if you create addresses for example, NFTs, then the starting character will be Z. And then users can already see, okay, I'm sending money to an NFT, or I'm sending money to a smart contract chain, or whatever.
Oh, that's interesting.
That's just some usability aspect which we try to take into mind. Yeah, so there is an issuer block is there, which will be important for NFTs. So basically, imagine that you mint an NFT on layer 1, and you put there an issuer, basically a public key. And then basically for the lifetime of that NFT, this issuer block is there as a stamp on the NFT that this NFT was created by this particular artist and no one can remove it. So this is proof of authenticity, sorry.
Authenticity, yeah.
hard to pronounce.
Yeah.
But this is like a proof of authenticity, which gives you the guarantees that this NFT is not fake. You can verify yourself that this NFT indeed was created by people, for example.
Right.
And no one can cheat you.
I mean, this is super important, right? So basically, if you mint an NFT on the layer 1, and this NFT gets transferred to another person, like let's say it gets traded, that other person can actually fully verify the provenance. Right? It can verify, hey, this NFT was actually minted by this artist, and this can never be changed, right?
Yeah, this can never be changed. Like
that's huge. I mean, that's huge. Yeah.
Changing it would be the same level of complication as basically changing anything or hacking the IOTA network. So I highly doubt it's possible.
Yeah, I mean, this is one of the big problems today, right? Where we have those centralized NFT marketplace actually giving you like some kind of confidence score if it's real or if it's not real.
Yeah, I mean, if they have history on it, then it might be real. You can never tell. With this, you can absolutely tell for sure. Right, yeah, nice. So maybe let's move on to the next feature block, which is something which we call the return amount block. And this has to do, I mean, it has a twofold feature, actually. So this not only lets you basically put conditions on the funds which you are sending, but it also makes it possible to implement directly layer 1 swaps. So imagine that I send you 5 Levy coins, and then I say, hey, Dom, take my 5 Levy coins, but if you take it, then send me back 100 IOTA. If you claim it, then it's yours, and I have the 100 IOTA back. If you don't, then I will take my 5 Levy coins back. And this is ensured and automatically processed by the protocol. So I can give you an offer, basically,
Right.
for whatever I feel like. That's one use case of it. Another use case has to do something with the dust protection, which is the other RFC. So we will talk extensively about it. In short, it's actually there to make microtransactions possible with the deposit scheme. This gives guarantees that the recipient can only consume funds or outputs which they receive if they follow the rules defined by the sender. That's in simple terms, that's it.
Yeah, no, it's really fascinating. I think the dust protection will probably have to do a separate show just on that because it's another big one. But these return blocks, so basically I could define a transaction that says, if you don't spend these tokens within the next, 24 hours, they will be returned back to me, right? So it's like, you can even think about them like gift cards of sort, right? So you can only be redeemed within the next 24 hours or else it expires, so to say.
Yes, exactly. So, I mean, usually these more complex use cases, like you mentioned, you will use another block as well, which is called expiration or time locks, which we'll talk about shortly. Yeah. So when you combine these blocks like Lego building blocks, then you can achieve such complicated use cases as you mentioned, for example. So you can say that, well, you have 2 days to claim it, if you don't claim it, then just get it back. Right. It's your bad. Okay, so we added another block called time lock block, which actually is just a rule that until the time which specified in here passes, no one is allowed to move these funds. So it's great for example, token vesting schemes. When you say, hey, someone just created their own tokens and they want to ensure the community that there is no rug pull. So what they say is, well, for 1 year, I cannot move my tokens. And then you know for sure that the protocol doesn't allow anyone to unlock it. A more fascinating use case of this is if you use these time locks for smart contract requests, then you can basically time your request. I can right now put a request to a smart contract chain, which I know for sure will only be executed tomorrow this time. I can time it, and the network ensures that no one can violate it. The next one, which is time-based, is called expiration. If you scroll a little bit down.
That's really fascinating, by the way. Like I never thought about these use cases and these possibilities, actually, that you could have these conditional transactions where you already send it today and it only gets executed tomorrow.
Yeah, or you can give allowances to your kids, and you just say, hey kids, take my IOTAs, but I put a time lock on it, so you can only have 100 IOTA per week.
That's amazing.
Yeah, so there's the expiration blocks there, which is similar in a sense to a time lock, but the big difference is that basically expiration means that you specify a deadline, an expiration deadline, and if the recipient does not spend or consume these funds before the deadline, then you as the sender gets it back.
Mm-hmm.
So why is it great? I mean, it again comes, the basic idea came from how you interact with smart contracts. So if I'm sending a request to a smart contract chain, I want to be sure that my request is processed. And if my request is not processed, well, I want to take back my money. So what I do is I send a request and I set an expiration day and say, hey, smart contract, well, you have 5 hours to execute my command. If you fail to do so in 5 hours, I just take back everything. I don't pay you nothing. So combining this expiration block with all the other blocks opens up these new time-based use cases, which were never possible before.
You could basically combine the expiration block with the, what was the previous one called?
Time block or return?
Or I think it was the issuer block. No, not the issuer block, but you could combine it with one of the other blocks where you can say, hey, I will give you these 100 Levit coins for 50 giga IOTAs. And this offer expires in 24 hours. If nobody takes the offer in 24 hours, I'll take it.
Yeah. I mean, it's definitely doable. The current version or what is online, it sort of lacks some of these concepts, which were really well pointed out by the community. So we are working on adding these features because they are possible. And I just want to thank them for reading it so thoroughly and giving up with all their suggestions.
Yeah, that's amazing. That's amazing, really. Is there, oh, there's another block, metadata block.
Yeah, there is another metadata, and there will be yet another one, which is called indexation metadata. But I mean, these are just blocks so that you can attach arbitrary data to outputs. Why is it important? Because this data will be interpreted by other applications. So, for example, when you call a smart contract, you encode the parameters of your request as metadata in an output. And then when the chain receives this output, they can parse the metadata and they can understand which smart contract you wanted to call and how. And the indexation block is something. Sorry, you had a question.
How much data do you have for this block?
Well, so the data is actually limited by what you can fit into one transaction.
Yeah.
And if I'm not mistaken, currently the limit is somewhere around 32 kilobytes.
Okay, that's a lot.
That's a lot. I mean, for binary data, it is. Of course, it's not enough to store a movie or something in there. But it's already a lot.
Like a small NFT.
Yeah, sure. Well, that you can do, or you should do. Yeah, so 32 kilobytes. I think that is the maximum possible upper bound right now. Yeah, and just like a couple of words about that indexation block thingy. This is actually a mechanism which I hope will be used by our decentralized identity solutions and streams as well, because it makes it possible to basically send data to an address which will be permanently stored in the network without relying on a permanode. So if you have the capabilities to do so, then you can very well just store your decentralized identifier permanently on the Tango, and no one can take it away from you.
So basically, any kind of data that I want to store forever, I would then use this indexation block, and it would never be removed.
Yeah, and then you can even index it, and that's why it's called indexation block. So you can just say, hey, give me all the data in the Tango, which is indexed to this address and by this tag.
Right. Fascinating.
Yeah, I think that was for the blocks. Yeah,
I mean, it's a very powerful concept, right? Because now you have transactions, and as you said, it's like Lego blocks where you fit together different Lego blocks and you get an entirely new use case out of it. And it's not happening on layer 2 with smart contracts, but it's also happening on layer 1 with the transactions, right? And I think that's a really powerful concept behind what we have built. And I think launching a new smart contract solution, you need to have a why, right? Why are you actually launching it? Because there's so many EVM compatible networks already out there, and it's easy to spin up a proof of stake blockchain and try to get adoption. But I think it's very difficult to define something like this, where you have a holistic architecture with the layer 1 being incredibly capable, right? And already having this programmability in mind for transactions, and then the layer 2 and both of them interacting with each other. I think that's really beautiful.
Yeah, and just imagine the future kids will not play with Lego; they will play with IOTA transactions.
I like that.
All right, let's move on. I think because it's we are kind of getting into the specifics.
Yeah.
Maybe if you open the one on GitHub, this
one.
Yeah, that one, because that the rendered version. If you click on it. Yeah, because we haven't talked about the output type, so I'm just quickly going to summarize. It's what you have been seeing with the other document. So just scroll down to where we had that nice picture of chain constraints.
Oh, that was at the bottom. Oh,
yeah.
Wait, no, it was here. All right, here they are. Yeah.
Yeah, exactly. So if you just scroll on the picture a little bit, because that gives the sort of the general understanding of how these new output types work. So what we wanted to achieve, and this is where I think Cardano comes into the picture as well, because they are working on similar stuff, is that we want to basically deploy state machines inside our UTXO ledger. And why state machines? Because state machines have a state, and then you can program how they can transition into their next state. And this is the idea behind some of the output types, like the NFTs, like the foundries, like the aliases. And the picture here actually says the first time you deploy such a state machine exactly there, then it basically marks a path in the ledger. So there is always like a chain of transactions which basically evolve our state machine. So there is always an objective truth on what is the current state and how we can progress to the other one. So the alias outputs and the foundry outputs and the NFT outputs use these chain constraints. The extended output does not. The extended output is solely there for the Lego-like building blocks. So let's get into just quickly summarizing what these different outputs do. So if you scroll a little bit down to where the extended output is laid out.
So right now we spoke about extended outputs, right? Before.
Yeah. So the extended output is actually a mechanism to transfer funds with attached metadata and different conditions and stuff like Lego blocks, which we talked about. The simple output is this is just what is already there in the ledger. It's not that important, I guess. So the extended output, as you see, it can hold native tokens, and it supports a huge variety of blocks. So, for example, you can have a verified sender on an output. You can attach metadata. You can get return amount, time logs, expirations, indexation, basically a lot of stuff. So this will be the primary vehicle to transfer native tokens and also to basically communicate with smart contracts.
Yeah.
Now the next one, which is alias output. The alias output itself was designed for smart contracts. So imagine this. Each smart contract chain has an account in the IOTA ledger, which is identified by this alias output. And this alias output has a permanent address. So even if your validators in the smart contract chain rotate and shift their keys or do whatever, your smart contract chain's address will always stay the same. So this was like a really hard requirement, because if I have to figure out like what is the address of the smart contract which I'm trying to call, and then I always have to go somewhere and fetch the information, hey, today which address it is, then it doesn't really work. So this gives a permanent address there. And you see that it has two controller entities, governance and state controllers. Basically, you can add some more control level and more governance structures into how your smart contract chain is actually governed. And you store the state commitments, like you say, their state metadata, for example. that is where you anchor the actual layer 2 state. Like basically your smart contract chain is immutably attached onto the main layer, and it's verifiable. You can just check it out. Yeah, I think your screen has went off again.
I wonder what it actually happens. I think it's probably the StreamYard software. It's kind of annoying. Yeah, let's continue.
Yeah, and as you see, we added a couple blocks there, namely the issuer and the metadata, so that, for example, you can guide the users of your smart contract chain to know, like what is the IP address or what are the addresses of my nodes where you can access it or whatever. And also you can have like a certifying body who says, hey, I do verify that this smart contract chain was created by someone, by this exact entity or person. That's what the issuer block is doing there. And the last one which I want to mention with these aliases is you see something which is a foundry counter there. So why is it there? Why do we count foundries in smart contract chains? And that's exactly because of the trustless bridge mechanism which we want to introduce. It's because we want smart contract chains to be as powerful as they want by giving them the opportunity to act as issuers of native tokens. So this is the foundation for the asset wrapping logic. A smart contract can create foundries which it fully controls. So it can create these foundries, and it can use these foundries to constantly change layer 2 and layer 1 assets, basically mint and burn them as the smart contract regulates it. So this is why we don't need additional trusted bridges in this whole architecture, because we made it so that smart contracts are also first-class citizens in IOTA, and they can act as controllers of foundries.
Yeah. So this is the secret sauce.
Yeah, this is the secret sauce.
I mean, it's amazing.
Recipe, so it's not secret anymore.
But it makes a ton of sense, right? Because you want to have smart contracts that are able to mint tokens natively. It's not just people that should do it. It should happen autonomously with smart contracts. And the beauty is exactly what you said, this trustless and feeless bridging between smart contracts. And no other network has that today, right? Such an architecture.
Not really.
Yeah.
Okay, so now we introduced foundries. The next one, I guess, will be the foundry output itself.
Yeah.
So, yeah, a little bit further down. The foundry output there.
Oh, that's here.
Yeah, you nearly skipped it. So what about foundry output? So foundries are the entities in our ledger which regulate the minting and burning of native tokens. I would like to point it out here that we completely transitioned from the old colored IOTA concept into this foundry-based concept. So a foundry does not have to have, does not convert IOTA tokens into assets. What it does is it basically mints them out of thin air. Anybody can inject their own tokens into the IOTA ledger. You don't have to buy like several mega IOTA to mint several million tokens. All you have to do is create one foundry output, load it with a little bit of IOTAs to compensate for the extra space you take up in the ledger, which will be negligible, most likely a couple MIs. And then you can start minting and burning tokens, basically creating them out of thin air and burning them into oblivion.
Yeah. And here you can then basically have like elastic supply, right? It's not that you have a strict definition of, hey, you only have 1 million tokens, it's capped.
Well, it depends on what you want. So each foundry has a so-called token scheme. Right now in the specs, there is only one token scheme. It's the most basic, simple one, which basically says, well, you can choose the maximum supply, and then, like circulating supply can never be greater than the maximum, but besides, you have no restrictions. In the future, we want to add some stuff like inflationary or deflationary token schemes, controlling the burn and minting flow. So you can actually implement new types of supply control rules, so to speak. All right, and another thing which I regularly see about the new native tokens concept circulating in the community is this question whether the foundries, how do they own the assets which they produce? So if there is a foundry and it means tokens, well, can a foundry burn it from my pocket? No, the answer is no, because the foundries only control the supply. They do not control what you can do with the token itself. So as soon as the foundry, distributes the tokens to user addresses, it has no control whatsoever on what the user does with the token. It cannot burn it. It cannot just transfer it to somewhere else. The user is in possession of the token completely.
Yeah, amazing. And can the token scheme change after the fact, after the founder's credit, or like it's always set in stone, right?
Yeah, good question. It's set in stone. So
that's very important.
If you deploy a foundry and you choose one supply control scheme, then basically your foundry gets a unique identifier and a set like that token scheme which you chose. And it's not allowed to change, because what would be the point of, having a hard cap on a supply if you can just change it tomorrow? We want to give guarantees to people that there will never be more tokens than this, or this is the amount of tokens which are actually circulating on layer one right now.
Right.
And another important thing which I wanted to mention here is that blocks there, you see there is a metadata block in the foundry output. So this is where issuers can basically store token metadata on chain. They don't need to have any off-chain or third-party registries. They can just upload the information here, and then anybody who receives this token can trace it back to this foundry output, which is currently there in the ledger, and they will basically have the information. Where does this token come from? Who is the issuer? What are the properties? And what I can do with it.
Yeah. Great. And the last one was NFTs?
Yeah, the last one was NFTs. The validation of this foundry is quite complicated, I would say, so I would rather not describe it. Yeah, the last one is NFTs. So the reason why we want to have NFTs as a distinct output is actually to be able to use them well with smart contracts. So you see, what is an NFT? This NFT is something unique, like it's a non-fungible token. It's a token from which there is only one ever in existence. So it's completely unique. So theoretically, what you could do with a foundry is you say, hey, I create a foundry, and in the foundry I say, well, maximum supply is 1. So I just created a native token, which is an NFT, because there will never be any more tokens which is the same.
Yeah.
But, and here comes the big but, as I mentioned earlier, token foundries do not control the tokens which are in the hands of the users. And that is a problem, because for NFTs, ideally, you want to have the metadata traveling together with the token itself. And this is just simply not possible with foundries. That is actually designed for fungible tokens. So instead, for non-fungible tokens, what we did is we came up with an NFT output type, which implements the logic of an NFT. And the most important characteristics is that it has a completely unique identifier. It has a verified issuer information present in it, and it can be sent to smart contract chains just like an extended output. So it can be used as a request. If I want to deposit my NFT to a smart contract chain to, I don't know, use it as a collateral in my DeFi application, you might very well do it. You can take an IOTA layer 1 NFT and just deposit it as collateral. Okay, so we had the verified issuer and the metadata, which is tied here, immutable metadata, so no one can change it once it's deployed, has a unique identifier. And here comes the big thing, is that each of these NFTs actually represent an account in the ledger. So as I mentioned earlier, they can own stuff. They can own other tokens, native tokens. They can own other NFTs. They can own any other thing which a normal user can own in the network. So I'm really excited to see what the community comes up by using this, because it's such a simple yet powerful idea that I don't know if I have the brains to understand what use cases this might bring.
I mean, that's amazing, right? NFTs holding NFTs and being fully capable of interacting within the network. And that's just beautiful.
Yeah. So and in a nutshell, these were the new output types. And yeah, I don't know if there's something at the bottom. Let's just scroll down to see.
Yeah. I mean, I think we covered a lot, right?
Yeah, these are just the technical descriptions of the unlock blocks, but I don't think we really need to get into this. Yeah, rational and alternatives. Basically, the conclusion here is that if we choose not to implement such a framework, then the smart contracts and tokens will likely not come to mainnet. So we really want to focus on pursuing this path and enabling all these nice features on our mainnet, so that people can actually build exciting stuff with it.
Yeah, as you said, it's really a necessity to have smart contracts on our mainnet, and it makes them so much more powerful. And
it's
so
2021, so how come, in 2021, I think IOTA feels a little bit like a baby project compared to other projects which are full of smart contract capabilities.
Yeah, we have to catch up
to do this.
Exactly. We have to catch up, and this can actually get us into the lead because it's so powerful, right?
Well, I also mentioned it a couple of times before, I think, to the community as well, that we are in a unique position now because we see what other projects are doing and we understand their concepts and we know what problems they run into. So since we have a fresh start now, we can already accommodate those issues when we design this system from the ground up.
Yeah, we have this unique architecture with the Tangle that makes them all the more powerful, I would say, because doing these on a blockchain would be less capable as well. So
yeah, I mean, maybe I haven't mentioned yet exactly why this UTXO model is so powerful for a tag like IOTA, is because it actually utilizes the capabilities of the UTXOs, parallel writes. I think you mentioned it before. Like Bitcoin uses UTXO as well, but you group things into blocks, so you don't really write parallel. However, in IOTA, and especially with the new consensus mechanism experiment, which is out there, I mean, which we just released this week for the DevNet, actually it gives like a really good presentation of why is this so powerful. You have realities competing with each other, parallelly writing to the same ledger, and yet amazingly still things work.
Yeah, absolutely. So I think we can't go through the questions today. Maybe we should do another another show because I think there was a lot to unwrap, and you explained it beautifully, and it makes it a lot more clear how powerful this entire concept is, right? And how the capabilities of IOTA have been like significantly extended.
Yeah. So by the way, I've also seen like many of the questions are regarding the dust protection. So I think it would be beneficial to have another AMA, maybe together with Max as well, because he's the mastermind behind dust protection.
Yeah.
And then we could answer all those questions, because then the loop or the circle is closed, and we know why we need the new output types. We know why we need the dust protection, and then people can better understand what is the motivation and why we want to take this route.
Yeah, I think that's a good segment, right? A good cliffhanger that we need to do another show. No, but this was really amazing. So thanks a lot, Levi, for clearing all of that up. And I think that the best action point for all of you is to look at the RFC on GitHub review it, add input, because right now we are in a sort of like public discourse where we want to get as much input from the community as possible. And maybe quickly about the next steps, right? So this stuff is already being implemented in Hornet and in B. And once it's fully finalized, we can really get started and already start building the libraries and already start building applications for that future. So I think it's really exciting.
Yeah. So we are building this for the mainnet. So
yeah,
you will see this first, I guess, on a Hornet-based development or test network.
Yeah.
And then but just want to everybody to understand that these changes are completely orthogonal to the consensus mechanism in IOTA. Therefore, with the upgrade to IOTA 2.0 or Core Decide, all these features will be seamlessly ported to that protocol as well. So they are not exclusive.
Yeah, no, that's really important because that also means that IOTA smart contracts and the tokenization framework and the output types can move from IOTA Chrysalis, the current mainnet, to IOTA 2.0 with no issues at all. So I think it's really powerful, right?
Yeah, actually, the origins actually come from the DevNet.
Exactly. No, but thanks a lot for your time, Davey, and thanks a lot for clearing that up. And for all of you that watched, please engage with us on Discord. We are happy to answer your questions and make sure to read the RC. So, and without further ado, I think have a good Friday evening, and let's start playing with Lego building blocks on the main.
Monday, then, but okay, and we'll have a fun Monday.
That sounds great. Cool. All right. Have a good evening.
Everyone.
Thank you. Bye-bye.